Hello everyone, welcome back. So in this video we are going to learn about sequential circuits. Sequential circuits. So if you are first time to my channel, please consider subscribing. So sequential circuits, its general block diagram will be like this. So you have combinational circuit and through feedback we are going to have the memory elements in the feedback path. So this is outputs and these are inputs. Okay, so this is the basic block diagram of a sequential circuit. So a sequential circuit, these memory elements or storage elements. So these are storage elements which are generally latches or flip-flops. Okay, latches or flip-flops. So in sequential circuit, the output depends on present inputs and previous outputs. Okay, so since storage is involved in this. Since storage is involved in sequential circuit, so output depends on present inputs, that is the combination of these present inputs and the previous outputs. The previous outputs are provided by this storage elements which are latches and flip-flops. Okay, so that means the next state. So upon the application of input based on the present state, you will get the next state outputs here. Okay, so have the clear idea of what is the next state, present state and inputs. So present state is the state before the application of inputs. Whatever the value or whatever the thing which you are stored in the flip-flops is called as present state, and this upon the application of input and some clock mechanism. So upon the application of inputs and clock mechanism, based on the inputs you will get the next state which also depends on the present state of the output. Okay, so this is called sequential circuit. Okay, so in sequential circuit, next state is a function of present input and past output. So next state is a function of present input and past output. Okay, so this is about sequential circuit and its block diagram. So the basic elements of sequential circuits are latches and flip-flops, and we have seen the basic elements of combinational circuits are logic gates. Okay, similarly the basic elements of sequential circuits are latches and flip-flops. That means all the sequential circuits are based or built based with latches or flip-flops. So generally we'll use flip-flops mostly. Okay, so we'll discuss about latches and flip-flops in the coming some course of time. Okay, next is what is the differences between combinational and sequential circuit. So what are the basic differences you have between combinational and sequential circuits? So combinational and sequential circuit, the first basic difference is combinational circuits does not have any storage. No storage involved because we use logic gates. So logic gates does not have any memory. So combinational circuits does not have any storage. But sequential circuit will have storage. Sequential circuit will have storage. And second, the basic elements here is logic gates. The basic elements of combinational circuits is logic gates, and the basic elements of sequential circuit is flip-flops or latches. Latches or flip-flops are the basic elements. Okay, so combinational circuits are comparatively easier to design when compared to sequential circuits. So sequential circuits are bit harder to design. So little bit harder to design the sequential circuits. And since combinational circuits have only logic gates, so they are faster in speed. They are faster in speed, and sequential circuits are slower in speed when compared to combinational circuits. Okay, so these are the basic differences between combinational and sequential circuits. Here no storage, and here storage will be there. So logic gates are the basic elements, flip-flops or latches will be the basic elements here. So combinational circuits are comparatively easier to design when compared to sequential circuits, and combinational circuits are faster in speed when compared to the sequential circuits. So with this we can enter into sequential circuits. So next we will see latches versus flip-flops. That means what is the difference between latches and flip-flops. So if you take a SR latch or SR flip-flop, so the basic thing or basic difference will be like this in the construction. So S and R are inputs, and there will be some enable input Q and Q bar. Similarly here S and R inputs, Q and Q bar are the outputs here. In the case of flip-flop also, but there will be clock pulse here. Similarly SR, Q, Q bar, enable, and SR, Q, Q bar, clock pulse. So this type of latch is called as, so generally what is the difference between latches and flip-flop? Operation is same. That means for the same inputs applied, latches and flip-flops will give you the same output. For the same input applied, they will give you the same output only, but the change is with respect to the method in which they change their output. The difference exists between latches and flip-flop in the method in which they change their outputs. Okay, so this is the basic difference. This is the basic difference between latches and flip-flops. So what is the difference is, latches are level triggered circuits. Latches are level triggered circuits. So this level may be either positive level triggered circuit or negative level triggered circuit. And flip-flops are edge triggered circuits. Flip-flops are edge triggered circuits. Similarly you have two types again, positive edge triggered circuits and negative edge triggered circuits. So negative edge triggered circuits. So these two are latches. So in latches you have enable input. In latches you have enable input. So if you make enable input high, then you can change the output at any instant. Okay, so if you make the enable input high, then you are free to make the changes in the output at any instant by changing the inputs. By changing the inputs, you can have the change in the outputs at any instant of time. The only condition in latches is making the enable input high. That means if the latch is positive level triggered circuit like this. So this is positive level triggered circuit and this is negative level triggered circuit, that is negative latch. This is negative latch and this is positive latch. Since the enable input is high here and the enable input is low here, so a bubble over here represents a low enable signal. So if the latch is positive level triggered, so you have to give enable input is equal to 1 in order to make this enable input high. Similarly, in the case of negative level triggered latch, you have to give enable input is equal to 0 in order to make this enable input high. Okay, so if you can maintain these two conditions in these two types of latches, then you are free to change the output at any instant by changing the inputs. Okay, so this is the basic operation of latch. Whereas in the case of flip-flop, this does not work. So flip-flop will have an input which is called as clock input, and all the flip-flop inputs these two SR inputs are synchronous with respect to clock. That means they are applied with respect to the clock. Okay, so they are applied with respect to the clock. So what is a clock pulse? So clock pulse here and a clock pulse here. So what is a clock pulse and why are these S and R inputs are called as synchronous inputs, that is synchronous with respect to clock? So what does it mean is, so a clock pulse is a rectangular pulse. A clock pulse is a rectangular pulse like this. So a clock pulse is a rectangular pulse with 50% duty cycle. So with 50% duty cycle, that means T on is equal to T off. Okay, so this off time period is equal to the on time period. So such a type of square wave is said to have 50% duty cycle. So clock pulse is a square wave form with 50% duty cycle. Okay, so the basic difference, as I have told you, the basic difference between latch and flip-flop exists in the way they change their outputs. So in the clock pulse you have two types of edges. So this edge is called as rising edge, or it is called as positive edge. It is called as positive edge, or it is called as leading edge. Okay, so it is called as rising edge or positive edge or leading edge. And there is other type of edge which is negative. So it continuously have this positive, negative, positive, negative, positive, negative edge, positive edge and negative edge. So this type of edge is called as negative edge or trailing edge, or it is called as trailing edge, or it is called as falling edge. Okay, so it is also called falling edge. So these are the two types of edges which you have, and based on that you have, this is called as negative edge edge triggered flip-flop, and this is positive edge triggered flip-flop. So if the clock pulse is positive, then it is positive edge triggered flip-flop. If the clock pulse is negative, having a bubble over here, so it is called as negative edge triggered flip-flop. So in flip-flops, if you change the suppose take an example, if you take a negative edge triggered flip-flop, at this instant if you have given S is equal to 0 and R is equal to 1, S is equal to 0 and R is equal to 1, so you'll get some Q is equal to 0. This we'll discuss later. Okay, so you'll get a Q is equal to 0 as it is reset condition. So if you want to change the output, suppose if you want to give S is equal to 1 and R is equal to 0, you can change the output of the flip-flop only in the next negative clock pulse. Since it is a negative edge triggered flip-flop, you can change. So you are applying at this negative edge, you are applying S is equal to 0 and R is equal to 1. So you can change the inputs only at this instant, that is on the next negative edge only. S is equal to 1 and R is equal to 0, and correspondingly you will get Q is equal to 1. That is, change in the output will occur only at its corresponding edges. Okay, only its corresponding edges. So at corresponding edges means if negative edge triggered flip-flop is taken, then you will have the change in inputs which reflects the change in outputs only at the corresponding negative edges. If you have taken positive edges, then the change in inputs will be reflected at the change in outputs only on the application of positive edges. Okay, so in between what happens? So in between, if you change S is equal to 1 and R is equal to 0, the flip-flop will take the input, but restores the same output, till the next negative edge flip-flop or negative edge of the clock pulse will occur. Okay, so this is the basic difference between flip-flop and latch. So latch, only one condition, enable input must be made high. So if enable input is made high, then you can change the output by changing input at any instant of time. Okay, but in flip-flop, if you want to change the output, you can change only at its corresponding edges. If it is negative edge triggered flip-flop, you can change the output only at negative edges. If it is positive edge triggered flip-flop, then you can change the output only at the corresponding positive edges. Okay, so hope you have got the basic differences between flip-flops and latches. Okay, so in the next class we'll discuss about each and every type of flip-flop in detail. Okay, thank you.